Good morning friends. Today we are going to learn again few types of errors. Before that, the revision of the previous topics is I am K.M. Rupnavar and I am teaching you CHA 5301 whose section number 1 is assay validation and statistical data analysis. From section 1, the chapter 2, I am going to teach you. The heading of the chapter is, as said earlier, statistical analysis and analytical figure of merit. Here, the first topic we learnt was errors, and error is a observed value minus true value. Error are of two types, as you know: systematic error, random error, gross error. And here the systematic error is also called as a determinate error. Random error is called as indeterminate error. We cannot determine it or we cannot avoid it. And gross error is the error which occurs in a larger quantity or the greater quantity, and in this method we have to avoid or we have to reject whole method or whole experiment. Firstly, in a systematic error, the operational error and personal error, these are due to only analyst. Here only the person or the analyst or the student who is performing the experiment is responsible for the error. Operational errors and personal errors are as follows. The example earlier I have given was sample treatment before measurement is often the source of major error in chemical analysis. For example, incomplete drying of analytical samples before weighing, mechanical loss of materials during sample dissolution from effervescence or from bumping. Next example is incorrect technique involving the transfer of solution. Next example is lack of reproducibility in solvent extraction method. These are the operational and personal errors. Next is a instrumental error. In instrumental error, again two types, internal type and external type. Internal type of error occurs in instrument itself, and external type error is due to environmental factors which affects the instruments. Third error is additive error and the proportional error. Here additive error has some absolute value no matter what the amount of constituent being determined. Simply, the additive error does not depend upon the amount of constituent which can be studied. For example, solubility of precipitate means precipitate it completely gets soluble in the solvent. Error in weights. Next, the proportional error has some absolute value, and this absolute value here depends upon the number of constituents of the solute. For example, impurity in standard substance which results in wrong value of normality of a standard substance, means the additive error does not depend upon constituents of solute. For example, dissolution of a precipitate or solubility of a precipitate. And the proportional error means the error has some absolute value, and this absolute value depends upon the constituents. absolute value depends upon constituents. And the last error is errors of the method. This error originates from incorrect sampling. This error originates from incorrect sampling and from incomplete reaction or incompleteness of reaction. For example, in a titration, difference between the observed endpoint and the stoichiometric endpoint of reaction means the experiment which we have performed, the endpoint of the titration is suppose 10 and the given or the stoichiometric endpoint is 9. That means due to errors of the method, there is a difference in observed endpoint and the stoichiometric endpoint which is given. And examples are given for the errors of the method are co-precipitation and the post-precipitation. You know the definitions of co-precipitation and the post-precipitation means simply the another material, another component get precipitate with the actual component which is of interest. These are co-precipitation and post-precipitation. These are the systematic errors. Now the random error. Second part or the second type of error is the random error. The random error. This error is also called as a indeterminate error. Error. The random error occurs due to slight variations in the successive measurements. Means simply same observer has performed an experiment number of times, but each and every time there is a difference in reading. For example, 9.1, 9.1, 9.2, 9.15, 9.18, 9.16, 9.11 and so on. Each and every time the reading is slightly variable. Means the same observer, same experimental conditions, same instruments, same solutions are used by the analyst, but there is a variations are observed in the readings. These are due to random error, and analyst has no control over these types of errors. We cannot determine it or we cannot avoid it. If sufficiently large number of readings, large number of observations or readings taken, this error lies on a curve. Error lies on a curve. See, here is a curve of frequency of errors versus magnitude of errors. Frequency of error is on y-axis and magnitude of errors on x-axis. Here the number of readings, suppose around 50 readings were taken by an observer and he has taken the mean of these 50 readings, and mean is given by value mu. Mean means the addition of the total number of readings. From positive and negative errors of the same magnitude, we can say that these errors occurs equally at the both sides. Means random errors does not give accuracy but gives precision. As you know, accuracy means the exactness of the reading, means true value or the reference value which is given is equal to the observed mean value, or the difference between true value and the observed value is very small. But in case of precision, there is a randomness of the readings, there is a repeatedness of the reading, but this value which we observe is not equal to the true value. It is away from the true value or the exact value. In figure, this is bell-shaped curve that is symmetrical about the mean. Symmetrical curve we observed, therefore symmetrical about the mean, and this curve satisfies the equation. This curve satisfies the equation S is equal to 1 upon sigma into square root of 2 pi into exponential of minus x minus mu. X is a x bar minus mu bracket square divided by 2 sigma. Here sigma and mu refers for the standard deviation and mean respectively of the total population. And whereas Raman letters or the S and X bar are used for sample of populations irrespective of the values of the population mean and the population standard deviation. Here X bar is the population mean, and the S is a standard deviation of population, not total population but given population. Now the last error is gross error. Third error is a gross error. They usually occur only occasionally, and are often occurs in very larger quantity. And these errors are due to the carelessness of an analyst. and this error seriously affects the accuracy, seriously affects the accuracy of the result, accuracy of the result. And common gross errors are due to incorrect conversion factors. These are due to incorrect conversion factors. As we have studied in the experiments how to prepare normal and molar solutions, molar solution, parts per 1000, parts per million. The solution preparation is much more important. When we told you to prepare solution of 1 molar and instead of that you have prepared the 1 normal solution, obviously the quantity of the solute is less in the solution. That's why solution is not of 1 molar. And when you use this solution for your experiment, obviously your answer is not correct or your result is incorrect. Then you have to completely reject the whole experiment. That's why the conversion factors are very important. Otherwise there is a gross error, and these errors are again due to unsuitable storage of sample, storage of samples. Means earlier in CHA 190 you learned how to use chemicals, how to store chemicals and so on, and each and every type of chemicals like concentrated chemicals, hazardous chemicals or non-hazardous chemicals, less concentrated solutions or the powder components or H2O2, each and every component or each and every chemical is stored in a variable way, so that the storage of the sample is again important. For example, H2O2 is always stored in the black bottle, and instead of black bottle, when you kept this H2O2 solution in a transparent glass bottle, then there is a oxidation or the free radical formation of the H2O2 as a OH radicals, and this OH radicals recombines and there is a formation of water, and this water when you use for experimental purpose there is no further reaction. Therefore the storage of samples is again the main cause of gross error. These are the main 3 types of